Hello, fifth graders. We're going to reverse the way we look at these two different kinds of numbers, the so-called mixed number and the improper fraction. We began by asking if we have a certain improper fraction like 76 seventeenths, what is the mixed number that is equal to it? And the reason we do that, we often in mathematics have a preference for the mixed number. And why is that? Well, when we see 4 and 8 seventeenths, we talked recently about the fact that that's just a little bit less than 4 1/2. We can easily picture it on the number line. Even though we're dealing with seventeenths, we have a very good idea where that number is on the number line when it's represented as 4 and 8 seventeenths. But if I hadn't given you the benefit of the previous videos about this number, and I'll say this number because it's the same number, and I just gave you 76 seventeenths, where is that on the number line? You've got to think about it. You've got to basically convert the 76 seventeenths to the 4 and 8 seventeenths to have a good idea of where it is on the number line. How big is it? And so at this point, if I were to suggest to you that we're going to start with a mixed number and convert it to an improper fraction, you might say, why are we doing that? Well, there's a very good reason why we're doing that. Two very good reasons, at least, why we're going to do that. For multiplication and division. When we get to fraction operations, add, subtract, multiply, divide fractions, mixed numbers are fractions. They're a special kind of fraction. Whole numbers are fractions as well. The whole number 3 can be thought of as 3 over 1 or 6 over 2. So the whole numbers, the mixed numbers, and the ordinary fractions are all fractions. We have to be able to take any kind of fraction, add, subtract, multiply, divide them. Don't be intimidated by it. We'll take it little by little. It's probably the most important big topic of fifth grade math, fraction operations. When we are asked to multiply or divide with mixed numbers, we have to convert those mixed numbers to improper fractions in order to be able to accomplish the multiplication or division. For now, you can just trust me that there's a good reason why we're going to take a mixed number and convert it to an improper fraction. We're going in the reverse direction of what we did in the previous videos. First, a little word about the English language. It's called an improper fraction. That prefix at the beginning, rather than in sometimes means not, but in this case, sometimes it's an im. The English language has a lot of variation. It makes it tough sometimes. Improper means not proper. Well, what does proper mean? Proper means correct, well-behaved. The example I usually give is the dinner table, particularly if you have guests at the dinner table at your home. Well, there are certain things that would be considered improper. When I was young, I was told, don't put your elbows on the table, especially when company's over. Don't slurp your soup. Things like that. Proper versus improper behavior. So in mathematics, when we call this thing an improper fraction, it's like we're saying it's bad. But I'm here to tell you it's not bad. There's nothing wrong with 76 seventeenths. It's a perfectly good number. The reason that it's picked up this name improper through the years is because if we just look at it in isolation, 76 seventeenths, it's easier to understand its value, easier to comprehend it. Where is it on the number line if we convert it to the mixed number? So we say this is bad, and we want this. But if we have to multiply or divide mixed numbers, then we have to go from the mixed number to the improper fraction. So that's the explanation of why we're doing it. You don't have to fully appreciate it right now. Just trust me, it'll be necessary. And if you think about how we converted 76 seventeenths to the 4 and 8 seventeenths, just try to think that we're going backwards. So Here's how to think about going from 4 and 8/17 to the 76/17. This whole number 4 is 68/17. We saw that before, right? 17 times 4 is 68. This is 4, and the 68/17 is 4, and we have an additional 8/17. So 68/17 plus 8/17 is 76/17. Okay? It's just the reverse of what we did earlier. The crucial thing to understand is the fact that 68/17 is the whole number 4. 17/17 plus another 17/17 plus a third 17/17 plus a fourth 17/17. 1 plus 1 plus 1 plus 1 is 4. 17 plus 17 plus 17 plus 17, or 4 times 17, gives you that numerator of 68 over the 17. Then you add the additional 8/17 to get the 76/17. There's a formula, ladies and gentlemen. Here's how the formula goes. If you want to convert 4 and 8/17 to an improper fraction, the denominator is going to stay the same. There's half of your result right there. So the question is, when you have 4 and 8/17, how many 17ths is it all together? So this denominator here in the fraction just is going to appear in the denominator of the improper fraction. Okay? And now how do we get the numerator? Here's the formula. 4 times 17 plus 8. We multiply this whole number 4 by the denominator, 4 times 17. And then we add the 8. This is to get the numerator of the improper fraction. I think even at this early stage, you can appreciate why this works, why this formula works. Because this 4 times 17, whole number times denominator, that's the 68. That's this 68. But then we have an additional 8/17, so we have to add the 8 up in the numerator there to get the 76/17. It's very straightforward, very logical. Whenever I present formulas or algorithms, they are steps we can follow to answer a question in math. But I always explain why. I don't want you just blindly using algorithms because I told you to. Like sort of memorizing, okay, here's this times this plus this. If you just think of that in isolation, it probably isn't going to stick with you for a long time. But if you understand the underlying math, then the algorithm, the formula will make perfect sense, and you don't really have to memorize it. It'll just make sense to you. This notation that I made over here, this is not necessarily standard. You may not find this in a textbook. But what I mean here is a mixed number. This is the whole number part. There's a W for the word whole number. And then a numerator and denominator. So over here, the W was 4, and the N was 8, and the D was the 17. So the whole number, and then the numerator and denominator. To convert this mixed number to an improper fraction, well, the denominator stays the same. It's like you got half the answer right there. And now you do whole number times denominator. So W, I'll use the raised on here, times D, and then we have to add the extra N there. This W times D was the 4 times 17, giving us the 68, because the 68/17 was 4. And then, of course, we had to add the additional 8/17. So that's always how it will work. Let's look at a new example. I constructed up above an eighths number line between 6 and 7. So here's the whole number 6, and then 6 and 1/8, 6 and 2/8, 6 and 3/8, 6 and 4/8, 6 and 5/8, 6 and 6/8, 6 and 7/8, and 7. Which, by the way, if we had continued that pattern that I just was saying when I was, counting the eighths, this would have been a 6 and 8/8, right? See the pattern? The 6 here, this 6, I suppose, you can think of that as 6 and 0/8. Now, we never write 6 and 0/8. We never write 6 and 8/8 either, really. But you can think of them that way. So you've got 6 and 0/8, 6 and 1/8, 6 and 2/8, 6 and 3/8, 6 and 4/8, 6 and 5/8, 6 and 6/8, 6 and 7/8, and 6 and 8/8. But 6 and 8/8 is 7. 8/8 is 1. 6 and 8/8 is 6 plus 1, which is 7. So let me get rid of that 6 and 8/8. It's important to know that 7 can be thought of as 6 and 8/8. You'll need to know that in the future for certain situations, but we generally don't write 6 and 8/8, we'll just write 7. And we generally don't write 6 and 0/8 because 0/8 is 0 and 6 plus 0 is still 6. So the question I have for you is, we'll put it this way. How many eighths altogether is 6 and 5/8? How many eighths altogether? Well, it's 5/8 past the whole number 6. How many eighths is the whole number 6? Let's go back up here underneath this 6. And right underneath here, how many eighths the whole number 6 is? Now, we've done this already. In previous videos, we've done this. I wrote something on the board like this. 6 equals how many eighths? And I told you that this is an absolutely basic, crucial kind of question for early in 5th grade that you'll be able to answer that. 8/8 is 1. 16/8 is 2. You go up by 8/8 each time, you're going up by 1. I'm not going to write them all out, see if you can follow it. 8/8 is 1. 16/8 is 2. 24/8 is 3. 32/8, going up by 8 each time in the numerator. 32/8 is 4. 40/8 is 5. And 48/8 is 6. And I told you earlier, you can think of that fraction, read it from top to bottom as a division. The whole number 6 is 48/8. And ladies and gentlemen, let's go back to that blank numerator or the question mark I had there. How do we get what goes here? 6 times 8. 6 times 8 is 48. 48 divided by 8 is 6. It's as simple as that. Notice how your whole number multiplication facts are crucial. And if you haven't mastered them, you need to very soon. And I don't really do that in 5th grade. This is something that if you're a little lacking on it, you need to, with help from home maybe, you need to work on that so that you know all of these facts instantly. So up here, this whole number 6 is 48/8. Okay? Well now, I've asked us to look at 6 and 5/8. 6 and 5/8 is 5/8 past 6. And the 6 is 48/8. So look what we can do here. 48 plus 5. Going back to that formula, I used the formula here, I showed it here in general. That 48, of course, just like here, I got it from 6 times 8. 6 times 8 plus 5. Okay? That 6 times 8 is 48. Plus 5 is 53. This is the answer to the question. The question was, how many eighths altogether is 6 and 5/8? And the answer is, it's 53/8. And it's very logical. Makes perfect sense. Why is 6 and 5/8 53/8? Because the whole number 6 all by itself is 48/8. The whole number 6 is 48/8. We have 5 more eighths. 48/8 plus 5/8 is 53/8. Later on, when I'm not presenting it for the very first time, I'll just do something like this. And remember, with a mixed number, there's an understood plus sign between the whole number and the fraction. We say and, which is addition. All right? So 6 and 5/8, we will say, is 48/8 plus 5/8. This is the 6 plus 5 more eighths, and that, of course, is the 53/8. It's the same analysis as before, except in the future I'll probably just go directly from 6 and 5/8 to the addition of those two fractions and ultimately to the 53/8. Let's look at a couple of more examples. And An early goal for 5th grade, and by the way, we have a textbook. I don't always agree with the ordering of the topics in any textbook that I use in any of my classes, whatever grade it might be. I will often go out of sequence. In my opinion, learning the definition of fraction is the number one most important thing in 5th grade math, so I start with it even though it's not first in our textbook. And then that seems to evolve nicely into this idea of improper fraction and mixed number. That's kind of the second topic that I cover in fractions. Soon, we will look at what's called equivalent fractions or equal fractions. And I've given you a little taste of that already. I usually do that with almost everything I teach. I'll give previews of it because anytime we're doing something in math, other topics, other considerations, other questions that we might have seem to be naturally there. So sometimes I'll go to it even though officially it'll be down the road a little bit. You might have wondered, I hope you did, up here when we were looking at this 8th number line between 6 and 7, you might have wondered to yourself, hey, what about that 6 and 4/8? Where does that appear to be on the number line between 6 and 7? So that point right there, which I've labeled 6 and 4/8, does that look like it's exactly halfway between 6 and 7? It is. It should be. It should look that way to you because 6 and 4/8 is exactly the same as 6 and 1/2. And there are others we could do up here as well. The 6 and 2/8 is 6 and 1/4, and the 6 and 6/8 is 6 and 3/4. Don't be intimidated. Some of you will appreciate it right now, but we haven't officially gotten there yet. It's probably the next big topic we'll take up in fractions, is looking to see why is 4/8 equal to 1/2, why is 6/8 equal to 3/4, and so on. And we'll look at it on the number line, and you'll become very, very confident about that and very knowledgeable about equivalent or equal fractions. But for now, we can say that 4/8 is exactly equal to 1/2 based on an analysis we used, I believe, in the last video. 4 is half of 8. Anytime the numerator is half of the denominator, the overall fraction is equal to 1/2. And you can see it clearly here with the eighths. The 4/8, 6 and 4/8 is exactly halfway between 6 and 7. So 6 and 4/8 is equal to 6 and 1/2. Okay, other examples before we close this video, other examples of going from a mixed number to an improper fraction. I didn't bother, ladies and gentlemen, using a ruler. I just made sort of a quick sketch here of the number line from 0 to 3, and then I made it into a halves number line. And I eyeballed these. I simply put a dot where I thought a dot that was halfway between 0 and 1, and then halfway between 1 and 2, and so on. So that we have these little jumps here, which are each 1/2. 1/2, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves. Okay? So the first half to the right of 0 is 1/2. And that whole number 1 is the second half to the right of 0. Then the next half after 2 halves is, of course, 3 halves. And then 4 halves, which is 2. And then after 4 halves comes 5 halves. And then the whole number 3 is 6 halves. Remember that division outlook on a fraction. 2 divided by 2 is 1. So 2 halves is 1. 4 divided by 2 is 2. 4 halves is 2. 6 divided by 2 is 3. 6 halves is 3. But let's look at these improper fractions that occur at 3 halves and 5 halves. Well, 3 halves is clearly halfway between 1 and 2. It's 1 1/2. 3 halves is 1 1/2. You can think of the 3 halves This is similar to something I just did with the bigger one, the eighths, right? Break that 3 halves down into 2 halves plus 1 half. 2 halves plus 1 half is 3 halves. But the 2 halves is 1, and 1 plus a half, 1 plus a half is what we mean by 1 1/2. What about the 5 halves? Well, the 5 halves is halfway between 2 and 3. You've probably guessed already, 5 halves is 2 1/2. But let's break it down. 5 halves can be thought of as 4 halves plus 1 half. And when we break down these fractions, we want to do it in such a way that this is a whole number, and then over here is less than 1. 4 halves is 2, and then we're adding 1 half, so it's 2 1/2. And 2 1/2 is 5 halves. 1 1/2 is 3 halves, 2 1/2 is 5 halves. This video is about going from mixed number to improper fraction. So if we have 1 1/2, we're just going to reverse the process that we have up there. We say to ourselves, the question is, how many halves altogether is 1 1/2? This whole number 1 is 2 halves, plus the additional 1 half, and 2 halves plus 1 half is 3 halves. It's right up here. It's just the reverse of what we just did. If you start with 2 1/2, and your question is, how many halves is that altogether? Well, right in the question, we could say we're converting the mixed number to an improper fraction. But if you ask the question this way, how many halves altogether is 2 1/2? Well, you know the denominator of that improper fraction is this 2 right here, that 2. And the whole number 2 is 4 halves, plus 1 more half gives you the 5 halves. The formula tells us to do 2 times 2 plus 1 to get the 5. 2 times 2 plus 1 to get the 5, and then the denominator stays the same. Over here, with 1 1/2, it's 1 times 2 plus 2, plus 1. 1 times 2 plus 1 is 3. So we get the 3 halves. Okay. These are the 2 very simple examples, 3 halves, or 1 1/2 being 3 halves, and 2 1/2 being 5 halves. 3 1/2, and there's certainly a pattern there. 3 1/2 is 7 halves. 4 1/2 is 9 halves. Can you appreciate that without the number line? The formula tells us 3 times 2 plus 1 to get the 7. 6 plus 1, 7. This 3 is 6 halves, plus the additional 1 half is 7 halves. 4 1/2 is 9 halves, because the 4 all by itself, the whole number 4 is 8 halves, plus 1 half gives us the 9 halves. Before we go on to another example or two, I have to make this point. Talked earlier about why something like 9 halves is called improper. If I were making up the names for things in math, I probably would have called something like 9 halves something different, because it's unfortunate, and this is a very rare situation in math. It's very rare that the vocabulary in math doesn't make sense. There are certain things, like later on you're going to learn a word like hypotenuse related to a right triangle. That's a word that we can't really appreciate, we just sort of have to accept. We can't figure it out on our own, we just have to accept that that's what it's called. There's some sort of reason based on ancient Greek or something why a particular side of a right triangle is called hypotenuse, but those are rare. Usually the way we name things and the symbolism we use in math makes sense, and you can imagine, well, if I were making it up, I'd do the same thing. Improper, though, the word improper in improper fraction, though, is a bit of a problem for me, because it might lead you to think there's something wrong with 9 halves. There isn't. 9 halves is a perfectly good number. It has a home on the number line. It's the 9th half to the right of 0. And of course, it's also halfway between 4 and 5. It's 1/2 past 4. We call them improper fractions because often it helps us to understand the number, where it is on the number line, if we represent it as a mixed number. But There really is nothing improper about 9/2. It's a perfectly good number. And in fact, to highlight this, I'm going to tell you something that's going to happen in 7th grade, and we may even start to do it late in 6th grade. In 7th grade, we're going to say 9/2 is a perfectly good number, and we'll use it. We'll give it as an answer. If I ask you to solve some kind of equation or something in 7th grade, and you get an answer of 9/2, I'm going to say to you in 7th grade, don't bother converting it to a mixed number. We know how to do that. We won't bother. And 9/2 is perfectly good. There's nothing wrong with it. For now, I'm going to be asking you, if you're working out certain things and you get 9/2, I'm going to ask you to represent that 9/2 as 4.5. Because it's easier then to understand its value. But there will also be times this year when we have 4.5 and we have to represent it as 9/2 in order to multiply or divide. So I hope this is something that's giving you a little bit of a sense of where we're headed and some of the protocols, some of the ways we're going to go about doing things. I just, at this point, want you to realize that it's not like 9/2 is bad. It's not like it's illegal. That word improper is a little bit of a misnomer, they say. Misnomer is a big fancy word. It basically means misnamed. This NOM there is actually the French word for name. NOM is the French word for name. And English draws heavily on French. A misnomer is something that's misnamed. So improper fraction is a bit of a misnomer. So just try to keep that in mind. And we'll do a couple of more examples. I'm a little bit torn right now, just now while I was paused. I was torn between should I use number lines or should I not? In the future, we'll probably, either in class or through future videos, I will still be using the number line to show certain fractions, why certain improper fractions are equal to certain mixed numbers and so on. But I'd like to see if you can sort of make that abstract leap right now. I've shown you some examples with the actual mixed numbers to help you see concretely why things work the way they do. But let's see if we could just jump to the abstract. One thing we could say here is, and this is what the textbooks would say, and many teachers and students would say, I have to convert a mixed number to an improper fraction. And Mr. LaBeouf told me that we're going to need to do that in the future when we are multiplying or dividing mixed numbers. We have to first convert or change them to improper fractions. I think it's legitimate to think at this point that you can do this. You can make that abstraction, make that leap and not have to actually draw a number line. Maybe you're kind of thinking about it in your mind, which is fine. And pretty soon you'll be able to do this abstractly. But I don't want you to just do 5 times 7 plus 2 over 7. That's correct, by the way. That's the formula that I showed you before. We can say here what we're doing is converting a mixed number to an improper fraction. But I think a better way to think of it is like this. 5 and 2/7 is how many sevenths altogether? See? And when you ask the question that way, then you already have the denominator. Because I just asked how many sevenths altogether is 5 and 2/7. So the denominator is 7, that just leaves the numerator. Now the formula tells us for this numerator, 5 times 7 plus 2. So it's 37. 5 and 2/7 is equal to 37 sevenths. Mixed number, improper fraction. Sometimes when we're working out problems, if we end up with 37 sevenths, I'll be asking you to convert it to the 5 and 2/7, which that's the first thing we did. We went in that direction. In the future, when we're multiplying or dividing with a mixed number like 5 and 2/7, we'll have to convert it to 37/7 in order to accomplish the multiplication or division. But why is it 37/7? Why does 5 times 7 plus 2 work to give us the 37? Well, it's because this 5, this whole number 5 is 35/7. And then we have an additional 2/7, right? The whole number 5 all by itself is 35/7. 35 divided by 7 is 5. We could count 7/7. I gotta see if I can do this now. And every time I go up by 7/7, I'm going up by 1. I have to get all the way up to 5. 7/7, 14/7. The numerator is going up by 7. I'm adding 7/7 each time. 7/7, 14/7, 21/7. That's 3. I did that 3 times. 7/7, 14/7, 21/7 is 3. 28/7 is 4. And 35/7 is 5. This 5, whole number 5 all by itself is 35/7 plus the additional 2/7 is 37/7. And it does work to get that 37 to go 5 times 7 plus 2. But 5 times 7 is that 35, and then this 2 is the additional, it's from the additional 2/7. What about 9 3/4? Can you do that one on your own? The question is, how many fourths is it all together? How many fourths altogether is 9 3/4? And when you ask the question that way, which is really the best way to ask it, because then you really understand what you're doing. We could say, here's a mixed number, 9 3/4. What improper fraction is it? That's how the textbooks will usually talk about it. But what we're really being asked is 9 3/4 is how many fourths altogether. So there's half the answer. The denominator is 4. And the numerator, of course, is 39. 9 times 4 plus 3. 9 times 4 is 36 plus 3 is 39. You will certainly be doing that. You see, when we fully understand and make our own a formula or an algorithm, we don't recreate the wheel the rest of our lives. We don't go back and think, well, why does it work 9 times 4 plus 3? If you fully understand it right now, then you're free in the future to just use the algorithm. The whole number 9 all by itself is 36/4. How many fourths is 9? 36/4. 36 divided by 4 is 9. If I gave you this, 9 is how many fourths? We saw this before, right? 9 is how many fourths? 4 times 9 is 36. That gives you that numerator. Okay, but then we have an additional 3/4. So, as all of you know, 36/4 plus 3/4 is obviously 39/4. One last thing before I close off. What do we never, ever do when adding or subtracting fractions? We never add or subtract the denominator. 36/4 plus 3/4 is not 39/8. No, it's 39/4. Keep the denominator the same. That's enough for now. If you think you get all of this, all of these videos that I've shown you thus far in 5th grade, you think you understand this, or you understand it 90% of it, you think you have a 90% understanding of everything I've talked about, you're in a very good place. Be confident, work hard, and have faith that you will understand mathematics. Mathematics is understandable. It's my job to make it transparent to you so that it's not a mystery. It's not, sometimes in our lives we see all these numbers, all these symbols, and it's just sort of a blur to us. What I want you to do is think about the basics, the definitions, and build a structure for yourself where you're very confident. You need to have confidence, ladies and gentlemen. I believe in all of you. You're going to learn math very well. So take care for now, 5th graders. See you soon.